In this video, we're going to look at carboxylic acids. We will look at their structure, some properties of them, and then how to name a few simple ones. We'll get started with looking at what carboxylic acids are. They are organic acids that contain a carboxyl group. Now, a carboxyl group is a carbonyl bonded to a hydroxyl. So here's a carbonyl. It's bonded to a hydroxyl, an OH functional group. And then that carbonyl carbon, it has to make 4 bonds. So it's going to bond to an alkyl group or even a hydrogen over on the other side. But this that I have drawn right here is the carboxyl group. So that is the functional group in a carboxylic acid. Now, if you'll remember, carbonyl groups are polar. And so you have a partially positive carbon, a partially negative oxygen, and then here we have a partially negative oxygen, partially positive hydrogen on the hydroxyl group as well. So it's a very polar group, which means that carboxylic acids that have 4 carbons or less will be soluble in water. Now, this is also an organic acid, and so it behaves as an acid, which is, if you'll remember what we have learned already about acids, is that they are proton donors or hydrogen ion donors. And so this hydrogen in our carboxyl group is what we call acidic hydrogen. It is what gets donated in an aqueous solution or in an acid-base reaction. That's the hydrogen ion that is going to react. So naming carboxylic acids is based off of the same IUPAC system that we have seen for other functional groups. For carboxylic acids, you're going to drop the E from the alkane name, so we'll be counting carbons, and then you'll add the ending oic acid. If there are any substituents present, you name them just like we have done in the past with a number and what the substituent is. You will start numbering your chain from that carboxyl carbon. And so that's always going to be carbon number 1. So let's just look at a few. I'll draw a couple here and we can look at how they would be named. Here is a fairly small carboxylic acid. It has only 2 carbons. And so 2 carbons in the IUPAC system is an eth prefix. So this would be ethanoic acid. So that's our systematic. Now this particular carboxylic acid is extremely common, and the common name is what is used more so than that IUPAC name. And so acetic acid is the common name, and so most of the time you're going to see it referred to as acetic acid, but you should know that acetic acid is ethanoic acid. You should know both of those. Okay, if we have a benzene ring attached to our carboxyl group, this is benzoic acid. Okay, and let's do one with a substituent off of the chain. And we'll put our carboxyl group here. Okay, so we need to count carbons. And remember, don't forget to count your carboxyl carbon. That's going to be always carbon number 1. Here's 2, 3, 4. So we have 4 carbons in our longest chain. And so that is a butanoic acid. And off of our second carbon in our chain, we have a methyl group. So that would be a 2-methyl butanoic acid. So named very similar to all of the ones that you have seen so far. Let's look at a neutralization reaction. These are carboxylic acids, so they are an acid functional group. If they react with a base, you're going to get a carboxylate salt and water. Those are going to be our products for that. So let's look at that reaction. I'll write a carboxylic acid here. This has 3 carbons in it. So it is propanoic acid. We're going to react this with a base. I'll just say sodium hydroxide. And remember, this is our acidic hydrogen, so that is going to bond to the hydroxide in our base, and that will form water. So that's one of our products. And what we have for the carboxylate salt is everything left over from our acid. So everything except for that acidic hydrogen. So I'm just going to draw what else is left here, including that oxygen. So remember, that hydrogen from our propanoic acid left as a hydrogen ion. So it left its electron behind, which means that that oxygen there has a negative charge. Our sodium from the sodium hydroxide is an ion, and so I'm going to write the positive charge there. In organic acids or organic compounds, if they have an ionic bond, those ionic bonds are usually shown by having those charges drawn, just because otherwise the rest of the molecule is covalent. And water then is our other product. So this is a neutralization reaction. The reaction happens at the functional group, at that carboxyl group. And so it doesn't really matter what else it's bonded to or how long that carbon chain is. The rest of the carbon groups, the carbon chain just kind of rides along. But it doesn't get changed at all. It's just the functional group where the change takes place. Now the name for this, and you don't have to know how to name these salts for our course, but the name for this one is going to be sodium propanoate. But you should be aware and be able to draw the product from a carboxylic acid reacting with a base to form this salt and water as the other product. Okay, and so that just is a quick overview of carboxylic acids.